Hey guys, welcome to the course. I'm a rising senior in high school who finished AP Calculus BC and got a 5, and I want to help cover the two most important topics in calculus, differentiation and integration. For part 1, we'll be focusing on understanding the concept of the derivative through the limiting process, and then we'll be taking derivatives of basic functions. Please use this course however you see fit. Whether you want to get ahead of the curriculum, whether you have a doubt in the topic, you want to review for the AP exam, or you just want a general overview of calculus. So I want to start by giving you a preview of the two main ideas of calculus, differentiation and integration. Differentiation allows you to find the slope of a tangent line for a curve at any point. As shown in the left picture, it is done by calculating the slope of the secant line of the 2 points on the curve, and then moving one point closer to the other one, causing the distance between them to approach zero through the limiting process. Differentiation can be used to find an instantaneous rate of change, which means that we can tell how the function changes at a point. For instance, the steeper a slope is, the faster the function is changing. If the slope is positive, the function is increasing, and if it's negative, it is decreasing. Integration, on the other hand, allows you to find the area under a curve bounded by the x-axis, and this is done through breaking the region up into a lot of rectangles and adding them up together, as shown in the right picture. By doing so, it could approximate the area under the curve better, and as the amount of rectangles approaches infinity through a limiting process, we can get the exact answer. Finally, I want to give you all some suggestions as you're entering a new journey through beginning calculus. Calculus stands out from all the other math subjects you've taken because it allows you to generalize many concepts from pre-calculus and algebra through the limiting process, creating a new way of thinking which you should embrace. For instance, in the previous slide, you can find the tangent slope at a point when you usually calculate slopes of secant lines through 2 points on a curve. Previously, we only also knew how to find areas of familiar shapes like squares, triangles, circles, and maybe ellipses. However, integration allows you to find areas of regions of almost any defined function bounded by the x-axis. As we could see, calculus develops previously learned concepts, allowing you to do more. My second suggestion is for you not to get intimidated by the amount of work that you have to do. People may be hesitant from taking higher level math courses as a problem requires 10, 15, or even more steps to get to an answer. However, even though there are a lot of steps in calculus, at one point you'll get used to the process to solve the problem. For instance, when you're learning the quadratic formula to solve for s, or when you're solving different types of equations during algebra, the amount of steps may have been a lot. However, at one point you became familiar with the technique needed, and you are not worried about the number of steps anymore. This is the same thing with calculus. As long as you know what you're doing, and you're familiar with the process, which is my goal throughout these videos, these steps will come naturally to you. However, I would highly recommend you to review all the functions that you learned from algebra and pre-calculus. Doing integration and differentiation, particularly integration, one minute you may be dealing with algebraic functions, and next minute you may be dealing with trig functions, then you might be dealing with logarithmic functions. You may need to manipulate your functions in a way such that you can differentiate or integrate these functions more easily. If you're familiar with the properties of different types of functions, the process in algebra will become a lot easier. Overall, if you're watching these videos, you've come a long way in math. And this is where everything from past units come together and it becomes very interesting. I wish you luck, and let's begin with differentiation.